So far, we talked about the separable differential equation. In our next classification, next category, we're going to discuss linear differential equations of order 1. So let us review, recall that at the beginning of our course, we talked about a linear differential equation of order n. Let y be equals to f of x, then the nth order differential equation is denoted this way. You have your coefficients in x, a and x, times the nth derivative of y, plus another coefficient in x times the nth minus 1 derivative of y, plus the middle terms, a sub 1x, the first derivative, plus a sub 0 x times y equals to a function in x. It can be a constant as well. So if you only focus on the first derivative, it means that the highest derivative in the equation is y prime, the first derivative, then we are dealing with the first order linear differential equation. Therefore, the first order linear differential equation is denoted by, very well, so you're going to only see these three pendants here. So you're going to have a sub 1 x y prime plus a sub 0 x y equals to g of x. Okay. So when you're dealing with the linear differential equation, if g of x is equal to 0, we call this equation homogeneous differential equation. So we can classify this as homogeneous differential equation if g of x is equal to 0. Otherwise, we call it non-homogeneous. So non-homogeneous DE if g of x is not 0. For example, let's take a look at a couple of examples and try to classify these linear differential equations. So the very first one is, well, you have y prime minus sine t times y equal to 0. The second one is t y prime plus 2y equal to 0. The third one, well, here we have y prime plus 2 over t times y equals to cosine t divided by t squared. Okay. So in either cases, we have the derivative of y minus a function in independent variable. Remember that you can replace everything that you hear by t. If t is independent, you get a sub n of t. You have y equals to f of t, a sub n of t, y n derivative of y plus a n minus 1 t, which is a coefficient. And then here you can just replace everything by t as long as t is your independent variable. So you can rewrite your first order linear differential equation as a sub 1t, a sub 0 t, g of t, and you can say that, hey, if gt is equal to 0, you have a homogeneous differential equation, linear differential equation, and if g of t is not 0, you have a non-homogeneous differential equation. So let us compare this. In the first equation, the coefficient of the first derivative is just 1. So a sub 1 of t is just 1. Then a sub 0 of t, the coefficient of y is negative sine t. A sub 0 of t is negative sine t. You're just comparing these two equations, nothing more than that. And g of t is equal to 0. What's the meaning of that? It means that they have a linear differential equation and it is homogeneous. Linear homogeneous differential equation. What about the second one? The second one, the coefficient of y prime is t. So a sub 1 of t is just t. A sub 1 of t is just t, comma. Well, the coefficient of y is just a constant. It is 2. A sub 0 of t is equal to 2. And finally, the function on the right-hand side is just a constant, it's just 0. So g of t is equal to 0. Do we have a linear differential equation? Yes, it satisfies the definition of a linear differential equation. So it is linear, and since g of t is 0, we have a homogeneous differential equation. Linear homogeneous differential equation. What about the third one? Well, what is the coefficient of y prime? The coefficient of y prime is equal to 1. So a sub 1 of t is nothing but 1. A sub 1 of t is just 1. Then the coefficient of y, is 2 over t. A sub 0 of t is 2 over t. We're good with that. We don't have any problem here. On the right-hand side, you have a function of t, which is cosine of t divided by t squared, which is in rational form. And it's not 0, it is cosine t divided by t squared. Is this a linear differential equation? Of course. Why is that? Because it satisfies the definition of a linear differential equation. Is it homogeneous? No. Why is that? Because your gt is non-zero. So linear, non-homogeneous differential equation. Our next step is to present method of solving a linear first order differential equation.